Good afternoon, everybody. Thanks very much for coming along to this session, particularly being the last one of the day on, what are we now, day 3, I guess. So my name's Nick Ward. I'm an Azure Technology Specialist. I work for Microsoft, based in Melbourne, and I focus on the Modern Apps platform. That is the services that are in Azure to help you build, deploy, run, manage modern apps. What do we mean by when we say modern apps? We're really talking about websites, mobile apps, APIs, business logic workflows, media-rich video style applications, live and on-demand streaming, that sort of thing. That tends to be what we mean by modern apps. Actually, I'm joined by a colleague of mine, Chris Allison, who's up the back. He's based in Sydney. He and I are the sort of the dynamic duo, if you will, of the Azure Modern Apps platform. So if after this session you have any questions that you'd like us to follow up with, would love to chat to you more about it in detail. Either Chris or myself should be able to help. I've got a ton of demonstration that I want to show you today about the Modern Apps platform that's available to you in Azure that you can use to build, run and manage and scale websites, mobile apps, APIs, etc. So I might dive straight in. Unless you've got a burning question, something really doesn't make sense or whatever, I'd ask you to please remember your question and ask it towards the end, because I've got a ton of content to get through, and I am going to do my best to leave time at the end within the hour 15 to ask and answer questions, because I know, there's going to be a bus waiting and everybody's keen to get on a roller coaster. So talking today, as I say, about modern cloud platform as a service. So that's an important point right off the bat. I'm not talking about virtual machines. I'm not talking about operating systems. I'm not talking about containers or anything you can do at that level of technology and below. I'm talking about what you can do at the platform as a service level so that you can concentrate on the code and content of your app and leave the software and hardware plumbing to the platform. Let Azure worry about all of that and just concentrate on what you want the logic of your application to be. The services I'm going to be talking to you about have a heritage within the Azure platform. They're not necessarily all brand new V1 services. We've had for a while the Azure Website Service in Azure, which has been rebranded Web Apps as part of the Azure App Service for some time now, and that's running an awful lot of websites in Azure. It's one of the most popular services that we have on Azure, and is running tens, if not hundreds of thousands of websites. Mobile services is a technology that's been in Azure for a little while as well for integrating with mobile apps. And BizTalk Services has been around for doing B2B communication integration workflow, particularly in the EDI space. So we've had some technologies that have been around in Azure for a little while, but we've noticed something. People are often building apps that span all of these technologies and more. So we've brought them all together into a package that we call the Azure App Service. Azure App Service is a platform as a service offering for you to deploy your websites to, deploy your APIs to, deploy your mobile app backends to, and deploy your what we call logic apps to. Logic apps being essentially workflows that string together different calls of APIs to get more functionality produced than the individual API call. App Service, a couple of context slides just to introduce where App Service sits before we sort of get into the meat of the demonstrations. App Service, we say loves software as a service apps. We've pre-integrated and pre-built capability into Azure App Service to connect your apps to a whole bunch of first and third party software as a service applications. So if you want to build applications that connect to Facebook or, that's interesting, Facebook or SAP, Salesforce.com, Twitter, Dropbox, OneDrive, Office 365, we've built what we call connectors, essentially API apps that I'll be showing you in more detail that make it really easy to build applications to any of those platforms in a consistent way with an SDK that hopefully makes a lot of sense and makes you very productive in building those applications. One other thing we like to say about Azure App Service as a whole is that you get all of this functionality for one low price point. So when you provision an app service environment, which has price points ranging from $0 free up to, I think the most you can spend on app service per month is somewhere around $1,000. But that gives you an extremely large platform for deploying your apps on. That's scaling up to some of the largest websites that we would be seeing in Australia. So it really is quite a cost-effective service. And you can deploy as many web apps, mobile apps, API apps, logic apps into that container as you like. So even in the free container, we do limit it, I think, off the top of my head to 10 in the free container, but you can deploy 10 websites, or 5 APIs and 5 websites, or 3 logic apps and 7 websites, or, I don't need to give you an elementary maths lesson, you get the picture. You can deploy as many as you like into that container, depending on, of course, the resources also that you've allocated to that container. Azure App Service forms part of a broader platform that we offer here at Microsoft for building, developing, and running applications. So Azure App Service sits here with the functionality that I'll be diving into in a lot more detail, but it integrates with a number of other services, such as notification hubs for sending push notifications to mobile devices, the development experiences that we have and that we integrate to. So whether you're building Windows apps in Visual Studio, whether you're using Xamarin to do cross-platform development, whether you're doing native code development in iOS or Android, whichever flavor you like or flavors, what I'm talking about today is equally relevant across all of those platforms. So this is not a system to deliver apps to the Windows ecosystem. It's to deliver apps to any user using any device that they might happen to use, and hopefully abstract away a lot of that complexity from you as the developer, so again you can focus on your application. There's of course a whole series of dev tools that we have with Visual Studio Online, which has just been renamed overnight, and a set of data storage and analytics technologies, and infrastructure services. If you want to go to that level of doing something quite customized with an OS of your choice and patch level that you want to control and all of those sorts of things, well, you can certainly do that as well. And the last piece of the puzzle being Active Directory integration for authentication in an enterprise scenario, allowing people to use their on-premise AD credentials in the cloud space, or indeed in more of a business-to-consumer type scenario where you want people to use their Facebook credentials, their Google credentials, whatever it is that they might want to bring on. So again, I'm going to be talking about App Service in detail, dipping into a couple of these other technologies as we go, but hopefully that gives you a little bit of context for where Azure App Service sits in the broader landscape. So App Service, I've said, have web apps, logic apps, mobile apps, and API apps. To give you a bit of a context for the demo that I'm going to be showing you, I'm going to be showing you pieces from each of these. So in the web app space, I've got a customer-facing website for a fictitious organization called Just Service that focuses on servicing cars. So pretty easy to understand scenario that hopefully you can relate to. So we've got a customer-facing website that customers use to log in, make inquiries about the company, and to book their car in for a service. We've got a series of logic apps that integrate systems together. So where the customer submits an inquiry to the website, we don't want to manage that inquiry through the website. We want to manage it through our CRM tool, which in this particular case is Salesforce.com. So we've got an API app, one of the built-in connectors for Salesforce.com that we connect our website to via a logic app. Classic use case of a logic app. I've got some data in one system, I want to get it to another system, use a simple little logic app to move it across. Scheduling the service, another little logic app to integrate the website with the technician's app or the mechanic's app. So the mechanic has a tablet that they use when they're servicing the cars, and they can see what cars are due to be serviced and work on those, mark them as complete, which then sends a notification back to the customer via text to say, your car's been serviced, ready to be picked up, good customer service. And so we're using a range of API apps to drive this integration. Twilio for sending the text message, a custom API app that I've written that allows bookings to be scheduled, so an API to expose the service to be scheduled. So that enables the organisation to have a B2B conversation with, say, a large taxi fleet. Maybe that taxi fleet wants to service a whole huge number of cars with this organisation. Instead of having to go onto the website to book in those cars for a service, they can integrate their fleet management system with the service booking API and simply have their own systems book the cars in for services directly with our API. And then a SQL connector as well. I mentioned that we love software as a service apps in Azure App Service, but we love existing technologies as well. We realise there are lots of databases out there and file systems and FTP servers and all sorts of more traditional technologies that we might want to integrate our apps with as well. And so we've built connectors for a vast range of technologies to incorporate them also. So let's have a look at websites first. Let's drill into Azure Web Apps as the first cab off the rank. So Azure Web Apps has a whole host of functionality, and I plan to show you quite a bit of it in the next few minutes. Let me just swap over here to number 6. Excellent. So here I am in the Azure portal, and the first thing I want to do is just show you how to provision a new web app. So to go from 0 to something that you can deploy a web app into. And so I can simply say new here, click on web and mobile, and the suite of web and mobile apps comes up, including web apps at the top of the list, and you can see mobile apps, API apps, logic apps, and then on to a range of other technologies there. Actually, if I just skip back for a moment and have a look at the marketplace, I just want to show you something before I drill into creating the web app itself. So let's have a look at the web and mobile section of the marketplace. So one thing I want to talk about here is the fact that you can deploy your own code to a web app, and that can be an ASP.NET web app, it can be Java, PHP, a whole range of different technologies, and you can just take your code and deploy it to this environment, or you can pre-configure it with a whole bunch of different CMS technology that we have pre-baked into the web app environment. So whether you want to run WordPress or Umbraco, there's a whole range of these here, from Joomla to Drupal. There's tens, maybe even hundreds now, of content management systems, e-commerce engines, blogging engines, a whole range that you can, as I say, they're pre-integrated into web apps. You can just select that as the platform that you want the web app to be running, and within a couple of clicks you'll have a WordPress website, for example, up and running in your own web app that you can then deploy your content to. Again, I'm just going to take a basic web app because I'm going to deploy an ASP.NET web app to it. So let's create a web app. And it asks me for a couple of pieces of information. What's the name of the web app? This needs to be globally unique, so I'm pretty sure if I just type Ignite, that's probably gone. So let me call it Ignite Hectagon, and that's all right, excellent. Please nobody start using the word hectagon, because if you do, it's going to make my life a misery. I'll have to think of another word. It turns out that word's not used very much, so I use it quite a bit. I select a resource group that I want to deploy this web app into. This allows me to manage related assets together as a group, and I can provision them all as a group, delete them all as a group, and so I'll create a new resource group, which I'll just call Ignite, and then I select an app service plan. Now the app service plan is the price point, essentially, that I was talking about before. It's the container that I'm actually charged for, and I can put as many web apps into that container, if you will, that app service plan, as I like. So I've got a couple already provisioned here. I'm going to select the Just Service plan and click Create. And that's it. That's all I need to do to create a web app. Really simple. Just give it a name a resource group, select an app service plan, an associated price point, hit the Create button, you're done. You've now got essentially a server running a web server that you can deploy ASP.NET, Java, PHP, whatever you like, to this environment. I'll come back to that one that I've just created in a moment, but in the meantime, I want to show you an existing one, which is the Just Service web app. So this is the web app that is underpinning my customer website that I mentioned in that scenario of the mechanics before. So I've got some essential details about my web app here, where it's running, what its status is, those sorts of things, what the URL is. You can see the URL here is justservicedemo.info. So you can have your own custom URL, of course. You don't have to use the azurewebsites.net URL unless you choose the free tier. And then we get a little bit of advertising because you do need to use the azurewebsites.net URL. But if you want a custom URL, you can move up to the shared app service plan. So here's my website running. As I say, it's just an MVC.NET web app, pretty vanilla, nothing incredibly exciting about the website itself, except of course the platform that it's running on underneath. I can see here a whole bunch of information. I can see some monitoring information about my web app. I can see information on the app service plan and the pricing tier that I'm in. So I'm in an S1 with one small instance. I can click that pricing tier, and let's say I'm expecting it to become a lot more popular, so I can move to a higher service plan, for example. It'll show me the price point, so you can see $95 a month for a S1 standard, $190 a month for moving up to a 2-core, 3.5 gig RAM platform. And I can just select that, and in a couple of seconds, that underlying plan will be enhanced to that larger model with no downtime to my web app. And again, I don't need to think about VMs or rebooting VMs or anything like that. The platform as a service environment handles all of that for me. I just say, I want to run on an S2, and now I'm running on an S2. And I could have selected a premium tier and moved up to much bigger environments if I want. And I can also set up auto scale so that this environment scales out and back into multiple instances for me automatically if I'm expecting a large amount of variability on my web app in this case. Keeping in mind that all of the web apps, mobile apps, API apps that you deploy in this environment are all sharing those same resources. So that's one thing to consider when you're sizing out what you want your plan to be. All right, so I can see that that deployment succeeded. That was the new web app that I created. So what I'm going to do here is swap over to Visual Studio and show you how I can deploy a brand new web app to my web app environment in Azure. So I'll just close that down and I'll select a new project. Let me just hide some of these things as well, get a bit more screen real estate. So let's select a web application, ASP.NET web application 3, that's fine. Application insights, if you haven't seen it before, I'll show you a little bit later. But really easy to just tick the box and have a whole bunch of telemetry about your website or your Windows app or your iOS app, or we support a whole bunch of different platforms and get deep insights into how that code is running how it's performing, what parts of the app are being used, what parts aren't, all those sorts of things. We'll have a look at that in a moment though. So I'm just going to select an MVC web app. I can say host in the cloud. Visual Studio and the SDK is completely integrated with web apps. So I'll host it in a web app. Click OK. And now it'll ask me which web app I want to host it in. Now I could create a brand new web app at this point and deploy to that brand new web app, but I've already built one, so I'm actually going to cancel out of that and just create the web app vanilla in Visual Studio. So to all intents and purposes at this point, Visual Studio may as well think I'm going to deploy it locally or wherever. It's just an ASP.NET web app. There's nothing particularly special about it that turns it into an Azure App Service web app. Azure App Service just runs ASP.NET, so it's all pretty vanilla stuff. That also means that if you deploy your web apps into the Azure App Service environment, you can always deploy them back on premise later if you want to. As I say, it's just ASP.NET. So let's go here and say publish. And we'll publish it to web apps, but this time I'll select an existing web app that I already have provisioned. We can see in my Ignite resource group, I'll select the Ignite Hectagon web app. It'll download the publish settings, which gives me the credentials to use web deploy to deploy my website to that web app. I select which configuration I want. I'm actually going to select debug because I want to show you in a moment some online debugging capability that we have. We can override any connection strings that we have. We can do a preview of the publish and go ahead and hit publish. So we should now find in a few seconds this thing will deploy to that web app that I created in Azure App Service, and we should be able to see it. All right, so there's ignite hectagon.azurewebsites.net, and feel free if you've got a device connected to Wi-Fi, you'll be able to hit this. This is a publicly available web app that I could scale up to a 50 instance, 8 cores in each instance website, and scale it up to some of the largest web properties that you're going to find, and all in the matter of a few clicks, deploy the app and away we go. So there's my web app running in Azure App Service. All right, back to the existing one. I want to show you a couple more details about what we've got going on here. First thing I want to show you is in application settings. You have the declarative control over a number of things. What version of the .NET framework do you want to be using? Do you want to use PHP, Java, Python? Which versions of those? Within a range of supported versions that are on offer. We generally keep them to the supported range of versions that are available in market. Various other settings, connection strings, app settings, essentially the web config file you have access to through this interface. Deployment. I can set up continuous deployment to this website if I want to have a more agile development process. And that's closely tied to a feature we have called deployment slots. Deployment slots allow me to create multiple slots to deploy my app to and direct users to. So in this case, every web app has a production web slot or deployment slot. And then in this case, I've got two additional ones, one called staging and one called build. If I go into the build one and go into the continuous deployment settings for this, you'll see that I've actually already configured continuous deployment here. Where are we? Scroll down. Deployment slots. Where are we? So it's got an active deployment, which I've actually configured through the existing portal. So what that means is when I go to the code for my web app, let me minimize that and go to, this is the project for the Just Service customer website. When I go here and let's go ahead and make a change. I'll just go to the views, I'll go to a shared view, the layout view, which if you're not familiar with MVC, this is a standard view that gets shared amongst all of your pages. And one of the things it has here is an action link, which effectively works as the title of the web page. And so I'm just going to put, let's put at Ignite, for example, as the title of our web app now. I'll go to Team Explorer and check in my pending changes. So it should hopefully pick up one change, which is that change I just made. So let's say Ignite demo and check in. So check in that one item, save changes to it and check it in. And it says change set 92 successfully checked in. Fabulous. Checked into my source control system. In this case, I'm using Visual Studio Online for source code control, but it could be GitHub or Dropbox or a whole range of different platforms for managing code versions. So now if I go to Visual Studio Online and have a look at my Just Service demo project, so this is where I'm managing the code and the build process for this web app. If I go to code, we'll see in here that under Just Service Demo, the web app, views, shared, and layout.html, we should see if we scroll down here, with a bit of luck, we see Just Service at Ignite, which is that change that I just checked in. And if we go to the Build tab, then we should see that a build has been kicked off when I checked it in. If I have a look at the build definition that hooks up my Azure web app, I can see that a build has been queued. And so this has been automatically triggered from the fact that I checked in my changes to the code repository. And that's now going to automatically deploy to the build deployment slot in my web app. At which point, I could have some automated testing go on and promotion into staging and production, or I could go through a manual process to what we call swap deployments. So if I swap back to the management portal here and click the swap button, what you can see here is that I can swap build with staging, for example, or I could swap from staging to production. So this allows me to promote versions of my website, test, and then promote versions of my website from build to staging to production, all within the confines of my web app. If I want to create a new deployment slot for whatever reason, it's very trivial. The swap itself, by the way, is just a VIP swap, so it takes a few seconds, no outage to your web app, and you've got the new version deployed. You can simply say new slot, give it a name, select whether you want to clone an existing slot for this new slot or whether you just want it to be empty, hit OK, and you know, a minute later or so you'll have another deployment slot which you can start deploying code to. Let me go back to the settings of my web app here. I'll show you that it takes about 8-9 minutes to build the code and deploy it to the build slot. So I'll come back to it and show you the result of that in the end. In fact, just to sort of the nothing up the sleeve type thing, if I go to the build slot here and click on the URL, hopefully it hasn't built already. It says that build is still running. Yep, started 3 minutes ago. But if we go to the build slot, so you can see at the moment it just says Just Service, but when it's finished building, we should see that just say Just Service at Ignite. One of the other really useful ways to use deployment slots is A/B testing or testing in production. So if I go down to networking here, I've got a couple of options for how I want to integrate the networking environment of my web app into everything else that I might be doing. So I can integrate virtual networks. If I have a virtual network deployed into Azure with various resources on it, databases, whatever, maybe other apps that I need to communicate with, then I can connect this web app with that virtual network and communicate back and forth between them. If I've got resources on premise that I want to connect to, I can do that via hybrid connections. So essentially set up a secure connection point from my web app in Azure to my database, for example, on premise via an agent that gets installed in the on-premise environment. Or if I want to be quite sophisticated about it, I can deploy what we call an app service environment. An app service environment is a preview feature. It's part of the premium app service plan tier, and it allows you to actually deploy your app service assets onto a virtual network. So they actually get deployed onto a subnet of that virtual network. They can communicate with anything on that virtual network or anything that that virtual network is connected to. So a more sophisticated Azure environment would typically have a virtual network in Azure connected to on-premise via something like ExpressRoute or site-to-site VPN perhaps. Now my web apps deployed in that app service environment get allocated private IP addresses on my virtual network and can communicate from there to anything in my virtual network or on-premise. It effectively becomes part of my, my overall networking environment. Traffic routing. So I mentioned A/B testing before. Here we can set up A/B testing or testing in production with traffic routing. What this basically says is, right now I'm sending 100% of traffic to my production deployment slot. But I might say, well, I've just tested out my staging environment. It's right, but there's a couple of experimental features in there. I want to know whether people like them or not, or whether they get used, or whether it changes users' behavior on the website. I probably wouldn't do this with my staging deployment slot. I'd have a different name for it, but nevertheless, it's the same concept. And click Save here updates the web app settings, and now anybody who's going to my website, 10% of the traffic is going to be directed to my staging deployment slot in this case, and 90% will be to the production deployment slot. And so I can get telemetry out of that staging deployment slot. I can have a look, did that new feature work? Are people using it? Do we need to tailor it anymore before migrating it into the main production slot and having all of our users get the benefit of that new feature? And similarly, I can go back to 0, click Save, updates the settings. There we go, it's done. And back to all of my traffic going direct to the production deployment slot. What else have we got here? Backups. Backups are an interesting one. So under backups, you can see here, you can just configure declaratively what you want to have backed up and how often you want to have it backed up. I think with the premium tour, we go up to, I think off the top of my head, it's 50 backups a day that you can schedule through this interface. I think on standard, you get up to 1 or 10 off the top of my head, but you can check the plan details actually at any time by clicking on the pricing tier here and verifying exactly what you're getting in the tier that you've selected. But here you see I've got storage configured, I've got my database configured to be backed up as well, and I've set up a schedule that in this particular case run once a day, and I've got these backups which I can restore in the event that I need to at any time. And again, I could deploy that, restore that to the production slot, I could deploy it to another slot as well for whatever testing that I might want to be doing. So backups are a really useful feature. Incidentally, everything that I'm demonstrating through the portal and through the UI, if you will, is all REST API based. So you can programmatically access any of these configuration settings and so forth and manage this in a more automated fashion. But for demos, the UI works really nicely. Also for learning it, or if you have a relatively small environment or you're just doing some testing, the UI works really well. All right, we've got a whole bunch of other stuff. The authentication and authorization model, we actually just announced an update to that last night, which allows us to have a very simple and uniform authentication model across web apps, mobile apps, API apps that allows me to integrate authentication to Azure AD or Microsoft accounts, Facebook accounts, and a bunch of other providers. And with just a fairly simple configuration, I can say I want this only to be accessible to authenticated users. And that's it. I just connect my authentication to Azure AD, say I allow this tenant, my own corporate tenant, for example, click the button and that's it. I don't have to worry about authentication in my app. App service will now restrict usage of that web app only to that tenant of Azure AD. So I can very quickly and easily restrict access to my app down to my corporate users or whoever it is that I want to have access. If you want to get more sophisticated and have different capabilities for different users and so forth, you can certainly do that as well. It just requires a little bit more programming in your web code, but you can hook into who is the currently authenticated user, what do I know about them, and so forth. Really simple programming model for authentication and authorization. There's also, if I go back to the overall page and click on tools, there's a whole bunch of more advanced tools that I have which are really useful for troubleshooting. There's some recommendations here based on how the website's performing. A bunch of things like Process Explorer, so I can see what processes are actually running on my app service environment. So you're starting to get a view into the underlying operating system that's running this environment for you. Kudu, there's a bunch of other things here, but I want to show you Kudu in particular. Kudu is a service management environment that every web app can be provisioned with that gives you quite a lot of debugging information, configurability information direct from the service itself. So I'll show you what I mean. I can go, for example, to the debug console, and you could see there either a command window or PowerShell, and we have a PowerShell console into this environment that's running my web app. So I can start to run PowerShell commands at this point to tailor and customize the environment that I'm using. Or I could do something like go into the web config file, click the little edit button, and I have direct access to the web config file that's running my website as we speak. And I'm connected to the production environment here, so of course with power comes responsibility. Beware, these are live changes that you can make to your running environment here. I wouldn't use it for production changes necessarily, but certainly for debugging and testing and so forth, really useful functionality just to be able to go straight to this environment, change it live, and see what impact that has on your environment. You can also connect to get diagnostic dumps, log streams, webhooks, a whole bunch of advanced functionality here that we can hook into, all provided for me as a service just by having hit create web app and deploy my code to it. And that's what the PaaS environment is really about. Giving you a very powerful, very scalable platform that you can use as little of as you want. If you've just got a simple little app and you want to deploy it, put it on a really small tier, pay next to nothing for it, you can do that. If you want a really large environment that's much more complex and integrated to an on-premise environment via a virtual network and have a number of advanced management capability, well, you have that as well. And it's the same couple of button clicks. Makes for very, very agile application development. All right, starting to run a bit short on time, so what I'm going to do is show you a website quickly, which is called movemetothecloud.net. So this is one to remember. Hopefully it's not that hard. to remember this one. MoveMeToTheCloud.net provides you with a web app migration tool. This is a tool that you can download, point it at an existing web app running on an IIS server in your environment today. It will give you a report on whether that web app will move to Azure Web App, and if it will or if it won't, it will tell you why not. Here are the reasons that it won't move, and you need to change that before you do the move. If you decide that yes, it can be moved and you want it moved, hit the button, it'll move it for you. It'll move the database for you. It'll move the whole thing up to the web app environment for you. We just did this actually for a customer, a government customer here in Queensland, just late last week. They allocated it a day and said if we can get a report out on this web app that we have on whether it can go to Azure Web App, we'd really appreciate that. So we went in. I didn't, but one of my colleagues did. And not only did he get that report, but he moved the web app to Azure, had it running, did all of that before lunchtime, so they did another one. So they got 2 web apps moved to Azure Web App in the course of a day, starting from nothing, ending up with 2 web apps existing, ported and running. The stats from engineering are about 60% of web apps that the tool has been run on can be moved without change to Azure Web App. The 40% tend to be things like classic ASP that would need to be upgraded before moving into the web app environment. So it tends to be older technology that won't necessarily move just as is. Just for a little laugh, here's my build deployment slot. So hopefully, if the build has completed, which it should have by now, yep, so if I go to completed, we should see that completed 10 minutes ago. So if we go to the build deployment slot, we should see Just Service at Ignite. Or we might see a blank screen. Oh, there it is, Just Service at Ignite. So yeah, deployed directly to my website straight from my code control. What you can see, just a quick note here as well, is Azure has a set of media services which gives you video on demand, live streaming of video. You can set up a broadcast quality, a film station or television station quality broadcast channel very quickly and easily using similar approaches to what I'm showing you with web apps, but do it for video apps, and automatically support iOS, Android, Windows, PS3, PS4, Xbox, etc., pretty much any video player out there, set-top boxes if you're in the business, but very extensible set of video technologies. But that's sort of just an aside from the concept of this presentation. All right, so there's a little bit of an introduction for you on web apps. Hopefully you're getting the sense that pretty quick and easy to deploy, a lot of functionality that you get, and you don't have to worry about web servers anymore. You don't have to worry about operating systems anymore. What about a high availability environment? It's already highly available. It's built into the platform. What about a DR environment? I can deploy this to 2 environments and put what we call Traffic Manager in the front, which will send traffic to both of those locations. If we lose one, it'll just start sending it to the one that still works. Very simple to have a very capable platform for running your web app. So Logic Apps. Switching gears, Logic Apps are about workflows. So it's based on the premise that increasingly our apps are built up of a collection of APIs and then different front ends that connect to those APIs and have a web front end or a mobile front end or whatever it is that you might want. Logic App says, well, we've got all of those APIs exposed now. How about we string them together into workflow processes that allow us to easily orchestrate different workflows and get functionality happening. So let's have a look at logic apps in a bit more detail. All right. So to kick off a logic app, I'm going to go to that scenario that I mentioned briefly earlier, which is I'm a potential new customer of this Just Service company, but I'm not 100% sure, so I'm going to go to the contact page and submit an inquiry. And let's fill out the form. I'm Nick Ward. My email is that. My phone is that. And my inquiry is, well, let's do Hello Ignite, just to put something topical in there. So I submit my inquiry, and what I should get back is something pretty standard. Thanks for your inquiry. All that's happened at this point is that has been entered into a database that underpins the website and responded back, thanks for your inquiry. But as I alluded to in my introduction, we as an organisation don't wish to manage our contacts with our customers via our website database. We want to do it via our CRM tool, which in this case for this organisation is Salesforce.com. And of course we've got integration to a bunch of different platforms. So if I go back to the start of the portal, over here there's my web app that we've been looking at and integrating with. And if I scroll down, we can see that we've got a logic app here called Upload Inquiries to Salesforce. And we can see a couple of things that it ran just now, and that was kicked off by me submitting an inquiry to the website. If we have a look at how that happened, I click on Triggers and Actions, and this now shows us the workflow that is being kicked off in this case. And what I'm doing is I've got a SQL connector. This is a pre-built API app that we've built that you can use to connect to SQL Server as an API call. So you define what the SQL statement is or what the stored procedure is that gets called when you access this API, and it exposes SQL Server functionality as a set of API calls that you can integrate into your applications. In this case, it also acts as a trigger for my logic app, and so I'm going to run it once a minute. So once a minute, it basically polls the SQL database. This is a SQL database running in the Azure SQL Database Service, but it could equally be a SQL Server running on a VM, or indeed a SQL Server running on premise. All of those formats are supported. And it gets out a series of rows with surname, first name, email, what the inquiry text was, basically all of the details that I just input into the form as a customer. What it does then is it connects to Salesforce, and it accesses the Salesforce Create Lead API and sends all of that information to it. It repeats over the rows, so it executes this call once for every row that it picks up, and puts up the surname, first name, etc. You just wire up. There's a template language here that you can use to access information within the workflow, manipulate the information in the workflow, and then reuse it in later steps in the workflow. And if I just have a quick look at the Salesforce.com API app we have here, you can see we can create accounts, update accounts, we can create leads, we can create opportunities, update cases, etc. There's a whole bunch of Salesforce functionality exposed through this API app. All right. Let's cancel out of that and go and have a look at this run, which we see happened at 5:46, which was just a couple of moments ago. We can see that the Salesforce connector succeeded. We can go into detail here and see, well, what information did my workflow send to the Salesforce.com API? Well, it sent this with Hello Ignite. What did it get back from the Salesforce.com API? If we go down here, it got back an ID. That's the ID of the lead, which we can now interact with further if we wish, and a success of true. And so if we go to leads here, And let me just click there to refresh my Salesforce leads. Go to the top one, and we should see Hello Ignite. So my Logic app has taken that information out of the database, uploaded it to salesforce.com for me, and it's all done that without me having to write any code. So a very agile environment is provided by Logic apps to provision different workflows very quickly and easily. One other thing I just want to show you, if I go back into triggers and actions for a moment, is the marketplace, the API marketplace. So I'll just wait for that to populate out. And you can see we've built out API apps for a whole bunch of different popular services. So, scrolling a bit too fast there. So, firstly, an important one is the HTTP connector. That allows me to connect to any REST API. Anything that exposes a REST API, I can incorporate directly into a workflow. But I have some nicer API apps built for Dropbox, Facebook, Office 365, SharePoint server. In fact, I just came from a session that Andrew Coates was running about building universal Windows apps against the Office 365 API. Is anybody in that session? A couple of people. So just an alternative to that. Don't worry, you don't have to have gone to that to understand what I'm about to say, but it's relevant for you folks that did. This connector API app exposes functionality that's available in Office 365, user information, calendar information, email information, etc., that I can incorporate in these Logic apps. I can also incorporate it very easily into any app that I want to develop. So it makes it really easy to write an app against Office 365 in this case. Or SharePoint, or Twitter, or Facebook, or Salesforce.com, or a whole bunch of traditional technologies as well. AS2, there's a bunch of BizTalk transformation patterns in there. DB2, Oracle, FTP, Informix, MQ, blah, 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 the list goes on. Any of these I can incorporate into my workflows really nice and easily. And of course, I can write my own. I can build my own API app and publish it. And let's now swap gears again and have a look at that. Dynamic CRM is not in that list yet. So the question was, is Dynamic CRM on the list? It's not yet. We do have planned support for it. One thing I have neglected to mention till now, so you've prompted and reminded me to, thank you. Web apps are generally available. Logic apps, API apps, and mobile apps today are in preview. So they're not fully built out from a functionality perspective. They are in preview. So yeah, do keep that in mind. But there's a lot of functionality for you to have a look at and test, and see where it might have applicability for you and your environments. API apps. Create, consume, and host APIs more easily. API apps do a couple of things. Firstly, they host your API. You can build your API using ASP.NET, just web API. You can use Java. You can use a whole bunch of different languages to build an API. It allows you to host it. It makes it really easy to authenticate to your API. It also makes it really easy to do cross-origin resource sharing. So have your API called from a controlled list of external domain names. If you want to share that API outside your organization, you can do that securely and very easily. The third thing it does is it provides an integrated link to Swagger documentation. So it documents your API, and from a developer perspective, makes it very easy to use your API because it essentially generates an SDK for you automatically against your API that you've built and published, and you can start using that from a Logic app or from any other app that you like. And so let's have a look at some examples there. All right. The first thing to note about API apps is actually just another announcement that we made overnight, which is that the functionality of API apps, we have had a lot of feedback that really useful functionality that I just mentioned, cause support, authentication, Swagger documentation, fantastic. Why isn't that stuff in web apps? Because if I'm publishing a web app that essentially has API endpoints, I want that goodness in my web app. And same for mobile apps. So what we've done, and as I say, just announced overnight, is we're incorporating all of that API app functionality straight into native web apps and into mobile apps as well. So that's not fully built out yet, but it's coming very, very shortly. Let's have a look at my jobs API. So this is an API I've written, again, just using ASP.NET Web API. Published it to this environment, very similar to what you saw before with my web app. I won't go through that sort of basic demonstration again, but you just create a web API, you can publish it, you can take existing code and publish it as well. And you get a couple of really nice things. The first is Swagger documentation. So I can see what functions my API is exposing here. And if I download the Swagger and open that up, we can see that we get all of the information we need to code against that API, including what the responses are and so forth, what parameters we need to pass to the API, what types there are, et cetera, et cetera. So there's a couple of useful things we can do with this. The first is I'm going to build a new console app here quickly to show you a connection point to that API that I've published. So let's do a new project. This time let's do a, where are we? A console application. Let me just minimize that down. All right, so we've got our console application here. We've integrated API apps into the Visual Studio tooling. So I can simply say here, add Azure API App Client. So let's click that. It asks me to select which API app are you wanting to connect to here. In this case, I want to select my jobs API app. So when I'm talking about jobs, I'm talking about car servicing jobs. So these are all of the bookings that have been made for cars being serviced. Click OK, downloads the Swagger metadata for that API, and it effectively builds out an SDK for me so that I can interact with that API very, very easily now without having to know a huge amount about how to do it or where it is or how it's used. So it'll just take a moment to add in the various NuGet packages, etc. for that API app. But keep in mind here that, again, Office 365, Facebook, Twitter, Salesforce.com, etc., all have API apps that you can right mouse click and add into an application of your choice. Excellent, so that's been loaded now. So now we can do simple things like set up a client. Where's our Jobs API app? So now I've got a new client to that API. That's all I need to do. It's really, really simple stuff. I can say, get a list of the jobs that have been scheduled. So var jobs equals client dot job dot get scheduled jobs. Get scheduled jobs is one of the APIs I've written. I also get an async version of that provided for me automatically. I didn't write anything on the back end to do that. It just provides it for you. So now I've got a list of the jobs that have been scheduled. So I might say for each job in that list, let's just write some information to the console. And let's get job.car registration number, who was the customer username that owns that car, and what was the special request that they put in about that job. Let's just do a let's do a read line. Just stop it. That's it. So not a lot of code there. Pretty simple. It's a pretty simple app. But for developing against an API, really, really fast and simple to get going. So there's my console app running now, and hopefully with a bit of luck, it should get back a list of the jobs that have been scheduled. There we go. So just access my API, brought back the jobs that have been scheduled. Question? How did authentication work for the API? Yeah, so in this particular case, my API that I'd published, I had set to public anonymous, which is just basically a checkbox setting in the API app. But just as easily, I could have selected another checkbox that was Azure AD authenticated. And then I would have had to authenticate my client to Azure AD in order to be able to use that API. I could have also selected another box to say internal. And what that means is that API app is only going to be accessible to other resources deployed in that same app service plan. So if you have API apps that you only want used within the context of the app service plan, just set authentication to internal, and it's restricted just to other assets inside that app service plan. All right, how are we going for time? 14 minutes. So we support versioning of APIs, and so you can connect to specific versions and then update as new versions of APIs get released. One other thing I want to show to that point actually is if I go here to, so this is the current management portal, go to API management. Have I been logged out? Let me just refresh this. And show you, we have a service called API Management. API Management allows me to essentially proxy any API. It doesn't have to be API apps. It can be any API. It can be running on premise. It can be running anywhere. It allows me to proxy that API and secure it and control it at that proxy point. So where are we? API Management. Let me go into here quickly and I'll open up the developer portal. It provides a whole bunch of things. It provides a developer portal on top of the API that you describe to it, provides this automatically just populated by the metadata that you provide, which gives developers the ability to sign up for your API, manage keys to access your API, manage versioning of the API. I'll sign in. Here's throughput and chargeability. It allows you to rate limit the API, so you could expose a free version of your API, for example, but put a policy on it that rate limits it to 5 calls a minute. You can't make any more than 5 calls a minute unless you move up to a paid version of my API. It allows you to secure it and say, I've got an API of 100 different functions. These 5 functions I'm going to provide for free. These 25 functions I'm going to provide under a paid subscription model, and all 100 functions I'm going to make available for my internal developers. So you can productize your API and chunk it up to different communities and control security of who has access to that. Oh, that hasn't logged me in. That's logged me back to the dashboard. So I'm starting to run short on time. So if I go into the APIs, these are available as the free API. I can go in here, click on an API. I can have a look at the calls that are available through that API. These are unsecured, so I can access them without signing in. But the jobs API I've been showing you is a secured API, so I can't see it because I haven't logged into this environment. I get detail about what the API is all about. I can hit the try it button, and then I get a little Postman-like interface to just try out this API, put in some different parameters, play around with it, see how it works. So API management, whole nother topic that I don't really have time to do justice with, but it's an Azure service that allows you to document, secure, productize, rate limit, analyze the performance of your API, and a number of other things besides. So let me now move to mobile apps. Mobile apps are a way to build a back end for your mobile apps that you want to distribute. And they can be iOS apps, Android, Windows, HTML. We support native SDKs for all of those environments, as well as technologies like Xamarin and Cordova. So we've got a lot of cross-platform capability within our mobile app technology. If I open up this mobile app is intended to be used by the car mechanics. So it allows them to see what jobs they need to be working on and mark them complete so that customers get notified that their car is ready to be picked up. But really, from the back-end perspective, there's really a couple of things that mobile apps does and makes your life easier when developing your mobile apps. So hopefully this is clear. Azure mobile apps are the back end, so you still need to write the client app that actually runs on the device, either in native code or Xamarin or Cordova, as I mentioned before. We provide SDKs for those to access this back-end functionality in mobile apps very easily. So what is that functionality? Tables. If you have data stored in tables that you want your mobile app, I might ask you to hold your question until the end because we've only got a couple of minutes left and there's a few more things I want to get through. Thanks. If you've got tables in a back-end database that you want your client app to be able to interface with, define those tables in the mobile apps service, and it provides you with REST API access to those tables. It also provides you with an SDK to access those tables from your client app. It also gives you an SDK capability to have offline access to those tables with synchronization, so that if your app gets disconnected, you've still got a defined data set which you can control what data gets synchronized offline, and then when network connectivity comes back, hit the button and it synchronizes the data for you as well. Overnight, we just announced we're doing this with files now as well. Files that are stored in Azure Blob Storage, we can synchronize those files offline via mobile apps to your client app. So really, really easy to build offline data capability in your app. APIs, essentially what I've been talking about with API apps, you can have directly within this API environment. Mobile apps is built on top of web apps, so everything that I talked about with web apps, including auto-scale and all of that capability is available to me here in mobile apps. Push notifications. Probably the most common thing that I see people using mobile apps for, at least initially, and then they start using some of these other facilities. Being able to send push notifications to iOS, Android, Windows, and a couple of other platforms as well. So all you need to do is get the credentials from the vendor of the device that you wish to support, plug those credentials in here, and now you have a very simple and very high-scale cross-platform push notification engine, which you can access from your client app. You don't need to maintain mappings of which devices have subscribed for notifications. You can have tags, so you can send notifications only to people that have registered interest in particular tags. You can have a tag as a username. So if you want to send a push notification to a specific user, register the username as a tag and you can push just to that particular tag. And it will go to that user regardless of whether the next device they pull out of their pocket is a phone or a tablet or a laptop. They probably won't pull a laptop out of their pocket, but you get what I mean, the next one that they use. So cross-platform push notifications, data I've talked about, authentication is the other one. So again, we've just remodeled the authentication model behind here, but if you want to build authentication into your app, whether Azure AD, Facebook, etc., very simple programming model to incorporate that authentication into your mobile app as well. So if I cross over here, and I'll just show you a quick example of what this looks like. So I'll start up another copy of Visual Studio, and let's get our mobile app service. This is an API I've built, an ASP.NET Web API, which leverages the mobile app functionality. So it does a couple of things. The first thing that I want to point out, let me just collapse that down, make it a bit more readable, is I'm exposing a job controller. So again, these are the job bookings, the car service bookings. It inherits from table controller. Table controller is a mobile app capability that exposes the job database table as an API for me. And essentially it builds out this code and an awful lot of functionality underneath this code for me. So if I want to get all jobs, just returns the query. So there's an API to get all of the jobs that are available in the system. If I want to get a specific job, I can just provide the ID as a string. Again, this is all exposed as an API. If I want to update a job, I can do that by posting a job item to this API. Push notifications. I've got that built in here as well. So this code basically sets up the credentials and the client for my push notifications service. And then once I've done that, I can build what I want my message, my push notification message to be. In this case, it's a message that says a car registration with a registration number is scheduled. So it just notifies the mechanic, hey, a new car has been scheduled to be serviced. And then it sends the push notification to those devices. I've got the app installed on this device, so if I go back here and make a booking, I'll log in. You've got to be authenticated on this app in order to log in and make a booking. So I logged in with my Facebook credentials. I was already logged into Facebook and had authorized this app, so it just went straight through for me. And I'll say, and special request for service, I don't know, let's just do Hello Ignite again and hit create. Again, just gone straight to the database. A logic app in the background will now fire up and send that to this API to post the job, send a new job. You see I got my notification there. The car registration ABC123 is scheduled. If I run my app, the actual app itself, this is now the client app, which makes use of these services, including the push notification that we just saw. And we can see here, hopefully with a bit of luck, let me complete a couple of these because I've done a wonderful UI job and I haven't put in scrolling into my app. So I'd love to be a designer, but clearly I've got a little bit of work to do. So you can see there, ABC123 Hello Ignite now exposed to me via the mobile app API. All right. So API apps, mobile apps. I didn't bother going back to the slides just in the interest of time. So just to summarize what I've gone through here, it's basically this deployment. It's a little hard to read, but if we zoom in here, we can see that we have, there we go, I should have a laser pointer here. Oh. Well, there we have our web app connected to a SQL database, connected to a logic app, to the Salesforce API, connected to a logic app, to an API app to make a booking, to the mobile app service to connect to the mechanics mobile app. And I really need to turn that off so I can so it's probably not too readable at the back, is it? But anyway, little architecture diagram of what's going on here in the various different web apps, mobile apps, API apps, logic apps all deployed, all within the Azure App Service container that you can see that square box around. So that's the unit I'm paying for. I can scale that out and back as need be, set up auto scale, etc., which this little animation shows very nicely. More usage, more power. And then when there's less usage, of course, it all scales back down again so that I don't need to pay more than need be. I mentioned this briefly before, but from a DR perspective, we can deploy any of these apps into any Azure region around the world. Web Apps is also a part of Azure Stack, so you can deploy this on-premise within the Azure Web App environment as well. Again, because we're just talking ASP.NET here, or Java or PHP, you can deploy it, a lot of this code wherever you like. Traffic Manager works with web apps, etc. very nicely, also works with any endpoint on the planet that you want to load balance between. It's basically a DNS load balancer. So works very well with web apps. We deploy the web app to 3 locations globally. Traffic Manager will route users to their closest web app so they get nice performance. And then in the event that we lose a data center or for some reason one of the web apps goes offline, then Traffic Manager just continues to route traffic to the ones that are left. So in summary, you've got a very capable platform here for running web apps, mobile apps, API apps, and logic apps. Very simple and easy to provision these environments, very simple and easy to manage them, provides a very agile platform for you to be deploying these technologies onto. So please complete a session evaluation. Would love to know what you think of the session and how we can improve. Of course, the resources are all going to be available, including this talk has been recorded, I believe. It'll be available on Channel 9 for you to go back to and have a look in more detail. Of course, head to the showcase for a $100 Azure PaaS. If you don't have an Azure subscription already, or even if you do, create a new Microsoft account, use the Azure PaaS as a trial with $100 worth of Azure value on it. Don't forget your name badge for Big Night tonight. Coaches arrive at 8:30, so you've got a total of 14 minutes to get there. Thank you very much for your attention. I'll stay around for any questions. Enjoy Big Night.